we've already seen several videos where we, learned what the Pythagorean theorem is and how it can be applied to find the sides of right triangles, and even to find the distances between points on the Cartesian plane. So this is the Pythagorean theorem. And just as a bit of a review, it tells us that if I have a right triangle, and if C is the side opposite the right angle, right? That's my right angle. C is that side. It's the longest side. We called that the hypotenuse. Hypotenuse. I'll write the whole word. Hypotenuse. Then the square of the other sides, the sum of the squares of the other side will be equal to C squared. So if this side is A and this side is B, the Pythagorean theorem tells us that A squared plus B squared is going to be equal to C squared. And we did several problems where we use this to solve different triangles. What I want to show you in this video is really a visual, you can view it as a visual proof of the Pythagorean theorem to see why this actually makes sense. And to understand that, I'm going to draw a little bit of a diagram here. So let me draw a little right triangle here. So let's say that that is my right triangle. And let's say that this is A, this is B, that is my right angle. Then that right there, this right here, that length right there is C. Now, what I'm going to do is draw this exact same triangle, but I'm going to rotate it a little bit. You're going to see what I'm talking about. This right here is the exact same triangle that I just drew, except I rotated it. So this is A, this is B, and now this is C. This is the exact. You could do this. You could take a ruler out and actually do it in a pick a, B, and C, and you can actually get. You just rotate this triangle around to the right like this. You could just rotate it like that, and you would get this triangle right just like that. Now I'm going to rotate it again. I'm going to rotate it again, and I'm just going to. You can imagine copy and pasting it, and then I will get this triangle. I will get that triangle just like that. And once again, this is A. This is B, and this is C. These triangles are all the exact same triangle, the exact same measure. Now let me rotate this again, and I'll get this triangle. I will get this triangle right here. And once again, this is A. This length right here is A. This length right here is B. And this is the hypotenuse of this right angle. This is C. Now, what do we have here? What do we have here? We have all of these right angles. And inside, I have this other square that is inscribed into this right angle. And I can prove to you, if you like, that these are also right angles. And why don't I just show it to you? You may or may not already be familiar that the angles in a triangle add up to 180. So if you call this angle x, you call this angle y, we know that x plus y plus 90 degrees have to be equal to 180. So x plus y plus 90 have to be equal to 180. Or you could say that if you subtract 90 from both sides of this equation, x plus y are going to be equal to 90. I just subtracted 90 from both sides. This disappears. 180 minus 90 is 90. And this x and y, they're all over. If this angle is x right here, so is this angle. Because it's the exact same triangle. So is this angle. So is this angle. If this angle is y, so is that angle. So is that angle. And so is that angle. Now, you may already, or may not already know, that if you have three angles that form a line, so let me draw it. If you have three angles that form a line like this, so let's say we have angle A, angle B, and angle, let me draw B a little bit different, angle B and angle C, just like that. And together, they kind of form you could imagine a semicircle, or they go from one line all the way back, that A, B plus C are going to be equal to 180. A plus B plus C is going to be equal to 180 degrees. They complete a 180 degree arc. Now, if you look at, let's say, this point right here on our diagram, you can see that angle x plus this angle right here, which I'll call it, well, I'll just call it, what should I call it? I could call it angle Z. X plus Z plus Y is going to be equal to 180 degrees. They form a line. So X plus Z plus Y, or maybe I should write it as X plus Y plus Z is equal to 180. Now we already know that X plus Y is equal to 90. So this is equal to 90. So 90 plus Z is equal to 180. Z minus, or both sides of this equation minus 90 degrees. You get 180 minus 90. I'm just subtracting 90 from both sides. So Z is equal to 90 degrees. So this is definitely, these are all 90-degree angles. Inside, their sides are all the same length of C. So this is a square in the middle of this diagram. Now, let's think a little bit about what the area of the square is. And there's two ways we can come up with the area of that square. So let me draw something here. So the first easy way to think of the area of the square was a square. This length is C, that length is C. To figure out the area, I just meant one side by the other side. It's C times C, or C squared. So if I want the area of that right there, it is C squared. C times C. Area is equal to C squared. But how else could we figure out that area? Well, we could say, well, it's also, that would be the area of this larger square, of this whole square over here, right? Minus the area of these triangles. Minus the area of these triangles. That also would give us the area of that inside square. So what is the area of this outside bigger square? Well, each of its sides are a plus b. A plus b. And so you take a plus b. If you want the area, you could say a plus b times a plus b, or a plus b squared. Right? That's the area of the outer square. But we still, to get the area of our inner square, let me see, area of small square. Area of small square. We still have to subtract out the area of these triangles. And what are the areas of these triangles? Well, the area of each of them, so we have to subtract out, the area of each of them is 1/2 times base times height, or base times height, AB. 1/2 AB. That's how big, that's the area of each of these triangles. Now we have 1, 2, 3, 4 of these triangles. So it's 4 times 1/2 AB. This is another way of getting the area of this inside smaller square. Now let's just do a little bit of algebra. We're pretty familiar with this, to essentially simplify the right-hand side of this equation right here. So a plus b times a plus b, a times a is a squared plus 2ab plus b squared. And then we have minus, what do we have right here? Minus 2ab, right? 4 times 1/2 is 2. So minus 2ab. Well, these cancel out. 2ab minus 2ab, we're just left with a squared and b squared. So the area of this inside circle, which is c squared, it's also equal to a squared plus b squared. And I've just shown you a visual proof for the Pythagorean theorem. Because remember, a and b were the smaller sides of a right triangle having c as its hypotenuse. And from there, we constructed this bigger diagram. Hopefully you found that fun.